11 and 12. We defined 4 terms: distance, position, displacement, and time. You guys remember what the definition for distance was? That's the easy one, right? Yep, Jack? Yeah, it's just how far something travels, right, or how far something's moved. Position is, I think Beth gave me that one yesterday, right? Because she added something good to the end of it. I remember that. Position is? Where something is in reference to. Yeah, where something is in reference to something else, or where something is relative to something else. Good. And that includes direction, right? It's if we're going to define where something is relative to something else, it's not just 20 kilometers away from it, it's 20 kilometers to the west of it, or whatever the case may be. Displacement is? Displacement is the one that if people have trouble with it, it tends to be displacement. Yep. Yeah, displacement is the change in position. So if we're going to say distance is delta d, and position is d with a little half arrow over, indicating that it's a vector, the direction matters, then displacement, the change in position, is going to be delta d. That's what delta means, right, is change. What are the units for all 3 of these? Yep, Marshall? Yeah, usually it's meters. We can use other units sometimes. Yesterday, you could have really used whatever units you want, kilometers, meters, whatever. It's going to come to a point when you pretty much always have to use meters. So that's why we want to kind of get in the habit of that. But there's certain situations like yesterday, the worksheet that you had yesterday, that you can use really whatever you want. Positive versus negative, what do we mean by that? Well, there is a direction associated with these, right? North, south, east, west, left, right, up, down, whatever the case may be. We usually assign positive. We usually make positive if the direction is north. Yeah. What else would it be? East, probably. Yeah. Right, up. Right? Typically, it doesn't have to be. You can define it really whatever way you want, but that's usually the way we end up doing it. Versus negative, of course, we define it as negative if it's going to be south, west, left, down, and so on. And finally, adding versus subtracting. This just comes back to finding the displacement. If you remember, there's 2 ways to find displacement. If we're given 2 different displacements and we want to find the total displacement, what are we going to do? In other words, if I walked 10 meters this way and then I walk 5 more meters this way, how do I find the total displacement? I'm going to add them together, right? So if I have 2 different displacements, I'm going to add those 2 displacements together. If I have 2 different positions, like for instance, my position right now is 2 meters from the front of the room. My position now is 5 meters from the front of my room. Those are 2 different positions where I am. What am I going to do with those to find the displacement? Subtract them, right? I'm going to say the final minus the initial. Now, remember with this one is, we don't have to know where I went in between. My initial position was 2 meters from the front of the room. My final is 5 meters from the front of the room. It doesn't matter if I got there in a straight line or if I did this and then climbed over a desk. I won't do that to get to 5 meters in front. In the end, it's final minus initial, however I ended up getting there. Does that make sense? Okay, that kind of takes us to one of those questions that you had in your worksheet. I think it was, I don't know which one it was, the track question, where we ran around the track. Okay, the distance traveled around the track is 400 meters. We went around the track twice. The distance traveled would be 800 meters, right? But the displacement would be what? 0, right? Because we end up where we started. My position hasn't changed. It doesn't matter how we got back to the same position as we started, whether we ran around the track in a nice oval like the track is, or whether we ran to 7-Eleven and came back and ended up at the same position. It doesn't matter. In the end, it's the same position, so my displacement is 0. Got it? Here's one for you. We talked a little bit about this yesterday, just a little bit. Let me give you an example here. Right now, I start 3 meters from the front of the room. Got it? So that's my initial position. Now listen carefully to what I'm going to say here. I'm walking 2 meters. Got it? I just walked 2 meters. Now I'm going to walk 3 meters in the same direction. What's my distance traveled there? I walked 2 and then I walked 3. What's my distance traveled? Yeah, it's 5, right? We just add them together, right? What's my displacement? 5 meters. My displacement is 5 meters, right? Because I walked 2 meters and then I walked 5 meters toward the back of the room. So we'd say 5 meters toward the back of the room. My distance traveled would be 5. My displacement would be 5 toward the back of the room. Got it? Same number, right? What about this one? What about this one, though? I'm going to walk 2 meters to the back of the room. Let's say that's north. It is almost north, okay? So let's say that's north. I walk 2 meters to the north. This time I'm going to walk 3 meters to the south. What's my distance traveled? 5 meters. Doesn't matter which way I went, right? When my distance traveled is 5 meters. What's my displacement? My displacement would be -1, or we could say 1 meters to the south. Why are those two numbers different? Okay, in the first case, it was 5 meters and 5 meters, right? My distance and displacement were the same number. Why are my distance and displacement different numbers there? In the second question that I gave you, Tyler?
Because you're ending up, let's say, in a negative reference.
Yes. Yes. Okay, even though I'm not always going to end up negative, though, right? Maybe I walked 3, then 2, and I wouldn't end up negative to where I started, right? Yeah, Kim? Because I changed direction. Good, right? When you travel in the same direction, the vector and the scalar are the same number, but when you change direction, then those numbers are going to be different. Does that make sense? My distance traveled, if I run 400 meters north and then 400 meters north, is 800. My displacement is 800 to the north. But my distance traveled, if I run around the track twice, is 800 meters. My displacement is 0. If I continue in the same direction, my distance to displacement will be the same number. If I don't, they're going to be different numbers. You got that? All right. Direction obviously matters for position and for displacement. It doesn't for distance, and it doesn't for time either, because time is a scalar. What's the symbol for time? We have 2 of them for time, although usually we end up using 1. Marshall? Yeah, we see t and we see delta t. Almost always we're going to use delta t, but occasionally we might use t. Okay, t just indicates a moment in time. Delta t indicates the interval of time. Whenever doing a calculation, we always use the interval, but you might have to get the interval by using moments in time. So for instance, if I said it's 8:57 when I started walking, it's 8:59 when I finished walking, the initial time would be 8:57, the final time would be 8:59, and delta t, which is what we'd use for our calculation, would be 2 minutes. Got it? So we're almost always going to use that delta t. What units do we use for time, typically at least? I kind of misled you a little bit there because I just gave you minutes, right? But usually we're going to use seconds, right? Got it? Okay, let's take a look at the worksheet that we had for homework last night, see if there's any problems with that. Let's have a look at number 6 here. It says a woman begins driving her car 200 kilometers north of Calgary, and sometime later, the woman in her car 100 kilometers south of Calgary. What's the distance traveled by the woman in her car? What's the displacement of the woman in her car? To be honest, displacement is often easier to find than distance. Even though it's a vector and direction matters and we have to deal with positives and negatives, displacement is often easier to find. I'm going to do that one first here, actually. My displacement, whoa, I don't know what happened there. My displacement here is going to be what? Add displacements or subtract positions? What do I have here? These are positions, right? This woman starts 200 kilometers north of Calgary, and that's where she is, or where she was, whatever. And she ends 100 kilometers south of Calgary. So these are 2 different positions. We're going to subtract these. It's final minus initial position. I'm going to say negative 100 kilometers, because it's 100 kilometers south of Calgary. Subtract 200 kilometers. Wait a second, shouldn't that be positive 200? Yeah, it is. We're subtracting positive 200, right? 100, negative 100, subtract 200 gives me negative 300 kilometers. I can leave it like that, negative 300 kilometers. Or I can make it 300 kilometers to the south. Got it? Now the distance traveled here, a little bit trickier. You can recognize here that because I didn't change direction, the number's going to be the same. Otherwise, it becomes a little bit icky when we're start here north of Calgary, we end up south of Calgary. Sometimes it's useful to actually draw a little map, almost. Let's say that this is Calgary right here. We start up here. This is my initial position. And that is 200 kilometers north of Calgary. This is my final position down here. This is 100 kilometers south of Calgary. We started up here. We went here. That's 200 kilometers. And then we went here. That's 100 kilometers. So my total distance is 300 kilometers. Does that make sense? Sometimes we don't need to draw that map. Sometimes it's useful to draw that map, especially if we happen to change directions. Like especially if we happen to go down to Calgary and then we end up going north again. It could be particularly helpful to draw those, a little map for that. Okay. Some of you are already done questions 7, 8, and 9, but I want to give you a few minutes right now, maybe about 4 minutes or so to do questions 7, 8, and 9 right now if you're not finished. If you are finished those questions, you got a short little break, I guess. Just sit quietly and read something or work on something for the next 4 or 5 minutes. Let's have a look at these questions now. I want to go over all 3 of them, all right, because they are a little bit trickier than 1 to 6, I think. Question number 7. Some of you may have struggled a little bit with question number 7. That's okay. 7 says, a boy walks 100 to the north, 200 to the east, 50 to the south, 200 to the west, and 50 to the south. What's the boy's distance traveled? That's an easy question, isn't it? Distance? How do we figure that out? We just add everything up. Do we have to pay attention to east, south, west? Nope, because distance is a scalar. Distance is a scalar. Direction doesn't matter. So the distance here, when we add all those up, is just going to be 600 meters. Is the displacement going to be 600 meters? Don't tell me what the displacement is yet, but is it going to be 600 meters? No? How do you know? We change directions, right? So distance is going to be something other than 600 meters. Might be useful to draw this one out. We got 100 meters to the north. We got 200 meters to the east. We got 50 to the south. We have 200 to the west. Oh, look, we're back where we started that way. And then we got 50. Oh, look at this. Aren't we back where we started? Yeah, what's the displacement here? 0. In fact, you couldn't actually do this question 7b, if it wasn't 0. Okay, if it worked out to be somewhere other than where it started, when it's a 2-dimensional problem like that, with east and south and north and west in the same question, that's a question that we will be able to do here in a couple of weeks, but we can't do it yet. We were able to do this one because they all ended up canceling out, or it worked out to be 0. Number 8. Number 8 says, a man begins driving his car 50 kilometers east of Banff. A while later, he's 300 kilometers east of Banff. Even later, the man and his car are 400 kilometers east of Banff. What's the displacement of the man and his car and the distance? The displacement is the easier one, I think, here. These are positions, so we're going to subtract the final minus the initial. What's the final position here? 400 kilometers east of Banff. What's the initial position? 50 kilometers east of Banff. What's the displacement? 350 to the east. What about this 300? Where do I put that in? I don't. What matters is where I end up and where I start. It doesn't matter how I got there, right? I could have went 50 kilometers, started 50 kilometers east of Banff, ended up 400 kilometers east of Banff, and gone to Edmonton in between. I didn't, but I could have, and my displacement would be the same number, right? So it doesn't matter where we go in between. Now the distance is a little bit trickier, although in this case, because we were driving east the entire time, I know my distance would be the same number, right? Has to be the same number. But it might be useful to draw a map here. Okay, let's do that. Here's Banff. I start 50 kilometers east of Banff. And then I am 300 kilometers east of Banff. and then I end up 400 kilometers east of Banff. This isn't drawn to a very good scale, but see what I'm doing here. Everything is relative to Banff. I start right here, 50 kilometers east of Banff, and I end up right there. What's my displacement? Well, if I was at 50 and I end up at 400, then my displacement's going to be 350 to the east. Or my distance, sorry, is going to be 350 meters. Good. Okay, let's take a look at number 9 now. A man begins driving his car 50 kilometers east of Banff. Let's draw this one out right away. 50 kilometers east of Banff. While later, the man is 350 kilometers east of Banff, or 300 kilometers east of Banff, I should say. And then we're, what, 150 east of Banff? My displacement for B is pretty easy, right? It's just final minus initial position. Doesn't matter where I went in between. My final position is 150. My initial is 50. So my change in position is 100 kilometers. Is my distance going to be the same number here? How come? Because I changed direction, right? I was going east, and then I turned around and went west. Even though I end up still east of Banff, I traveled west, right? So let's draw this out here, my path. I started here, I went here, and then I went here. What's my distance traveled if I go from 50 to 300? That would be 150, right? Sorry, 250. Yeah, whatever, 250. 50, I get part of it, right? 250. And then I go, how far am I going this way? From 300 back to 150. So 150. If I traveled 250, and then I traveled 150 back the other way, my distance traveled is 400. Got it? You guys comfortable with that? Okay. You probably didn't notice this because it happened at 8:45 this morning, and your phones are all over on the side. But at 8:45 this morning, there was a practice quiz went up on Google Classroom. We call it Fake Quiz Number 1. It's going to be remarkably similar to Real Quiz Number 1. Fake Quiz Number 1 is due tomorrow. Okay, you're going to work on that tonight, and we'll check it over tomorrow to make sure you're okay with it. Then Real Quiz Number 1 will be Thursday. Again, not the same quiz, not the same thing, but if you're able to do Fake Quiz Number 1, you should be able to do Real Quiz Number 1. Does that make sense?